Hello, Advanced Geometry. I'm going to take you through the basics of area. So first of all, area is always in square units. So we're going to have answers with centimeters squared or feet squared, whatever unit's squared. The base and the height must be perpendicular. So you always have to look for perpendiculars in order to find area. So you should never find the area unless you know you have a perpendicular. Okay, and we'll do one of these where you can cut it into different pieces. We'll do one of those on the back. So rectangles, obviously they automatically have the perpendicular, so base times height. Same with squares, side times side or side squared. Parallelogram, so notice you have a little dashed guy in the middle, so that is representing a perpendicular height. So this base goes all the way across. And to find the area, you do the base times the perpendicular height. It's tempting to use this slanted height here, but you're not going to use that for area. You would only use that for perimeter. You need that perpendicular height. Okay, same with triangles. So triangles, you're going to use, again, a perpendicular height, and the base goes all the way across here. And this is half of a parallelogram. So you just do 1/2 base times that perpendicular height. Kites and rhombi have their own special formula that you can use. And so that's 1/2 diagonal 1 times diagonal 2. And that is indicating the diagonal all the way across the shape here and here. Okay, now the reason why we can use diagonals for these two shapes in particular is because their diagonals are perpendicular. That's the only reason we can use this formula. Okay, lastly, we have the trapezoid. So you're going to do 1/2 the height times base 1 plus base 2. Again, you have a perpendicular height. And again, the bases are all the way across, and those are the parallel sides. So on these 6 examples, I want you to try these yourself. If you don't see a picture can be helpful to draw to help you out. But please pause and try these. Okay, welcome back. So the area of a rectangle, we're going to find that. So I'm going to draw myself a rectangle. I'm going to mark in my right angles. I know I have all these perpendiculars already. And what I know is the perimeter is 44 and a side length is 12. Well, from back in chapter 5, I know that the opposite sides of a parallelogram are congruent. So the opposite sides of a rectangle are congruent. So this is also 12. And then I need a base times a perpendicular height. Well, I don't know that, so I can figure it out because all those sides should add up to 44. So I take away the 12s and I get 20. So x is equal to 10. All right, so now I know my perpendicular height is 10. So the area is just simply 12 times 10, which is 120. Now, my units, I have linear units of inches, so my area units are inches squared. Next one, I have a square. Draw that, put in all of the perpendiculars, and then mark my 4 sides congruent. The area is 121. So this time I know the area is 121, and I'm trying to figure out the perimeter. Well, I can use this area to work backwards to figure out the side lengths, because I know side times side is 121, or in other words, 121 equals s squared. Okay, I'm going to square root both sides. So you get s equals, now your algebra teacher will tell you it's plus or minus 11 when you take that square root to solve. Obviously in geometry, we're only going to deal with the positive. There's no negative lengths. Okay, so that's a linear unit, so inches on the length. Perimeter, obviously, is just 11, 11, 11, 11, so we're going to have 44. And perimeter is also a linear unit. Next one, so always look for the perpendiculars. It's really tempting here to say it's got to be just 12 times 7, but notice there is no perpendicular to indicate that is the height. That is not the height for the 12. Okay, the perpendicular here tells you, okay, I want to use this as my base and then the 10 for my height. And in a parallelogram, opposite sides are congruent, so I'm going to use a base of 7, perpendicular height of 10. So my area is going to be 70, and that will be feet squared. Down here, so here's your introduction into these weird dashed lines. So all of that is indicating that this is a perpendicular height when this triangle is on this base of 5. Now, that 5 is only representing this length. Okay, we're finding the area of the shaded triangle. This triangle out here is just the dashed lines you have to try to ignore. They are simply telling you the perpendicular height that goes with this base of 5. Okay, so I'm going to do my formula, 1/2 the base I'm going to use is that 5 here, times the perpendicular height is given as 4, and then you're going to solve. Okay, when you're multiplying this out, you just have to imagine you're only applying the 1/2 one time. So I could do 5 times 4 is 20, half of that is 10. Or I could do half of 5 is 2.5 times 4 is 10. Or half of 4 is 2, 2 times 5 is 10. But I only apply the 1/2 one time. And then units squared. Because I don't have any given units, I just say u squared. Next one, so I'm doing the area of a rhombus. Okay, they're given the diagonals. Honestly, don't even need a picture because that's just doing the formula. Okay, again, you only apply the 1/2 the one time, so 4 times 6, which is 24, and that would be inches squared. Okay, find the area of the isosceles trapezoid. So the isosceles doesn't really matter. If you were finding the perimeter, then it would be nice to know that it's isosceles. But to find the area, you don't care about that 13. That 13 does not matter for area. The 12 is what you want to focus on because that's the perpendicular. Okay, so we're going to do 1/2 the perpendicular height times base 1 plus the base 2. All right, so 1/2 times 12 is 6. 10 plus 20 is obviously 30. So you get 180, and then obviously units squared because we don't have a given unit. Okay, back here. So here is a shape that we don't have a formula for. Now, the other thing that you should have in this picture, it's kind of impossible to do without it, is know that these are all right angles. So given those are all right angles, you want to think about splitting this up into pieces. You know how to find the area of rectangles, right triangles, that kind of thing. Okay, so pause and try to split this up and find the area. Okay, welcome back. So there's many ways you can do it, but I'll just do it this one way. So I'm just going to draw in these two perpendiculars. So now I have two rectangles and a right triangle. And you're just going to add up those pieces. So this triangle, rectangle is 3 times 10. So that's going to be 30. These other guys, you kind of have to figure out their sides. Okay, so I see a 2 here and a 10 there. So this height should be 8. And then on the bottom length, this is 10 and this is 3. So you can kind of think of this whole thing as 13. Okay, so that means if I take away the 8, this is 5. And then 10 minus 5, this is also a 5. All right, so that middle rectangle is going to be 40 centimeters squared. So kind of ignore that 8 now. And then this rectangle or triangle is going to be 1/2 5 times 8. So that's going to be 20. So I'm adding up my 3 pieces. So 20 plus 40 is 60 plus the 30. That area should be 90 in centimeters squared. There's other ways to do that as well. Okay, this is going to be a new concept, and people have a hard time with this. And I guarantee it's going to be on your quiz. It's going to be on your test. Okay, so what you want to look at here is, first of all, we're focusing on just the shaded triangle. Remember, these dashed lines are just indicating perpendicular heights. So I have 2 perpendiculars indicated. That means I could find the area of this shaded triangle in two different ways. So I'm just going to show you what I mean. So let's say I use this perpendicular. So there's the 12 is my base. So 1/2 12 times its corresponding height is 4. Okay, so that's going to be 6 times 4, which is 24 units squared. Now, I could find the area of this shade using this perpendicular instead. So that formula would be 1/2. Base here, again, the 8 is indicating this is my base. So that 8. And then its corresponding height is this h. All right, well, I can't calculate that, right? But since I'm finding the area of the same triangle, I know that its area has to be 24. So I'm just going to set it equal to 24. Now I can find the h. This is going to be 4h. And then divide, obviously. So the h is going to be 6. And we don't have units, so I would just say 6 units. Okay, so I'm going to skip number 9, just so I have time to go through 8.3 a little bit. So keys to success here is 100% you got to be organized with your work. You're really going to work on that this year to get organized. And then you have to be good at your unit conversions. You've definitely done this in science, but we're just going to go through it again. And I'm going to use just this as my example, but as we know, 1 yard is equal to 3 feet. But when you're doing a square yardage, that is going to be different. So 1 square yard is literally a square. That is 1 yard by 1 yard. Okay, but when I split this into feet, it's going to be 3 feet. So I split that into 3 pieces by 3 feet. And then I split that into pieces. So each of these is a square foot. So in a square yard, you actually have 9 square feet. So you just have to be careful with that. 1 square yard is 9 square feet. So let's just look at converting like 8 square yards. We're going to convert it into square feet. So what a lot of times people do is they're like, oh, well, let's see. 1 yard is 3 feet. And then they just multiply by 3. Well, look how these yards don't cancel, right? They don't have the same exact units. So I need this to be a square yard. So I'm going to square everything. But you got to square the top as well. And now those yards squared will cancel. Okay, but you're going to actually multiply by 3 squared. So 9 times 8, so that should be 72. And then you have your feet squared. So just be very careful with converting. Okay, lastly, so this is the type of thing in 8.3. Rashad wants to wallpaper his room. The dimensions of the room are 20 feet by 15 feet, and the walls are 8 feet tall. So you kind of want to think three-dimensionally, like look around the room. You're going to have 4 walls. So if I draw a wall, that wall is going to be 8 feet tall. And then one of the walls is going to be 20 feet. Okay, another one of the walls is going to be 8 feet tall and 15 feet. And if you think about just a normal room, there's going to be 2 of these and there's going to be 2 of these. So you're going to have that much area and that much area, and we're going to convert that because we're going to buy stuff in square yards. So whatever area you get to wallpaper, you just want to make sure that you're going to convert that into square yards. So we're going to have feet squared, yards squared. And remember, it's 3 feet to 1 yard, but you got to square everything. So that's how you would convert this area into square yards. And then obviously you're going to divide by this 6 square yards to figure out how many rolls, and then multiply by that $95 to get a total. Okay, so yep, just be very careful with units on these. Try to stay as organized as you can with pictures.